Yeah, let me share. I currently have only one question which I can validate, but yeah, we can go over the test data for other, you know, scenarios. So this one, Shankar, if I'm not wrong, you were validating this question.
Yes, yes, Revathy. Sure.
Okay, okay. So yeah, maybe for others, right? So yeah, this question is logistic regression classifier. We have to apply gradient descent optimization. The first part is cost function, sorry, the loss function. But this one, I don't think, yeah, Sumil had automated it, right? So this is
Yeah.
something we have to do manual, right?
No, Sunil automated everything. Only thing is
Oh,
we
the
need
cross entropy also, cross entropy loss.
the formula will be given directly to us. I mean, we can take it from the PPTs. This is without regularization. This is the loss function for logistic regression, and the hypothesis is a sigmoid function for logistic regression.
Hmm.
And they
So
get
in this Python program, it's not under the gradient, isn't right? It's under, is it under entropy?
logistic regression. Two parts to it, right? So gradient descent is the one. If it's a gradient descent one.
Hmm. Right, right. Now, what I meant to say is this one we have to do it manually using Excel, or do we have the
It's
Python code for this one?
yes, yes. It completely automated it. If you go to that Jupyter notebook, right? So in the gradient descent, so this is the one. So yeah, exactly. You're at the right location, and this is the data frame. And for
Oh, okay.
others, yeah,
Sure, yeah, we can run this program then and then validate it if it matches this. And one question, the actual output Y had, how it is 0.5?
yeah, it's not actual output. This is hypothesis output. So it is one. If you see the h theta function, right, or a hypothesis function, it's a sigmoid, 1/1 plus e power minus theta transpose of x. No, if you go to this is loss function, but whereas h theta in this h theta of x is a sigmoid function.
Can
If
you
you go,
Okay.
write that function? Yeah.
go ahead, go ahead. In the so if you go to the Jupyter notebook, the formula also printed there. So so this is the h theta where first one is loss function and second one is theta update rule without regression, without regularization,
Oh, here.
and this
Okay.
is the sigmoid function. And initial thetas are given to us. Initial theta are given like all are zeros. It's given in the question. Initial thetas.
Correct. Right.
So initial because theta is zero, initial thetas are zero. It will become 1/1 plus e power 0 into x. So it will become 1
Hmm.
by 1 plus e power 0. E power anything power 0 is 1. 1 by 1 plus 1 is 1 by 2. That's why all are 0.5, 0.5, 0.5. All predicted Y's are zero point 0.5 in the first iteration. H of x.
Okay.
Our hypothesis output is because initial theta of 0. And then that's the first part. And then we need to compute theta 1. So using the gradient descent, we need to compute the theta 1. So the update rule for theta 1 is given in the above formula. And just above. Uh,
Yeah, yeah, got it.
yeah,
Okay. This is the data update.
this is
Okay.
the update rule. And alpha also given in the question. Learning rate
Correct.
is, I think, given as 1. Alpha is given as 1.
Yeah. So the x 0, right? That one he's defaulting it as 111 once.
No, this yeah. If you go to the question again back, how these x1 and x2 and actual values come. So actually, Madam explained in the last session. They mentioned that's the
Oh,
trickiest part
this
in the
one,
question.
yeah, this is fine, but there is x 0, no? Yeah, x1 and x2, these values are taken, but
You mean
x
x naught?
0, x naught.
X
X
naught is
naught
generally all ones.
once, yeah. Okay. So yeah, I thought we'll just validate, this output.
Hmm.
Okay, so here theta 1, this is after iteration 1, what are the values of theta, right? So
Right.
here only it is minus 0.2500. Uh, oh, okay, so this is the, where here they've given the first
Correct. This
iteration
is the
only.
right. This if we can do. I mean, this is might be a Excel formula based output. They didn't share the Excel formula, but after computation here also, the Sumils code also generating the same values.
Okay, okay, yeah. Great, yeah.
But they asked
Mm,
us to calculate using the L2 regularization. The question next iteration they asked us
correct.
yeah.
The alpha is 1 and L2 regularization constant is 1.
So last term is added, no? Here. Yeah.
Sorry, yeah, here alpha is given and theta is initialized to 000 and lambda, oh sorry, this is without regularization.
First part they asked us to
Yeah, yeah.
calculate the loss without regularization, and second part they asked us to find out the theta using gradient update with regularization, L2 regularization.
Oh, okay, okay. Yeah. So, yeah. So the second part we have to run this, with this parameters. Minus 0.500 and the loss function is 0.6 and should but FYI this program is not giving this tabular format and all, right? In the interest of examination, can we write this alone?
No, no.
Iteration, no,
No,
right? Yeah,
also. You have to write table also.
the table also.
If we, is it possible to print this values also?
No, no, I think we can write also, right? I mean, like this also you can write and just highlight how we are calculating. So table and all will be time waste, right? We have to build because we don't know if they will ask in the same format in the exam. So after
Yeah, I think
calculation,
this
we can just
one we
highlight.
can initialize. I mean, x hat we already know. At least x hat we can take it from this h naught of x, right? So, and then y is the target y this one. But yeah, and then we have to do that subtraction and then initialize with x naught. And this one, I think we have to do this, at least have an Excel formula ready to fill this formula. Maybe this one we can directly take it from the program, like minus 2.5.
I think we can ask Sumil if we can print the table also, or the iterations we may need to
Okay,
write.
won't it be too much to ask for your skin?
I
I don't know.
agree.
I don't know. Any questions from anyone?
Yeah, theta 2 and theta 3, I think needs some correction in the program.
No, here he means theta 1 meaning this is only
Yeah, that
theta
is
0, theta 1, and theta 2. So, I think this is like after iteration, it's the vector of the theta.
Is it?
Right, Samshara. This is first iteration. This is the vector he printed, and theta naught, theta 1, theta 2 values are printed there. Theta naught is right in the
Yeah.
Excel. It's
This
represented
minus
as blue naught. Yeah, this is the vector printed there. And next iteration in the question it didn't ask. They didn't ask that.
Oh, it's only okay. Okay, fine, fine. Yeah.
theta 0. Okay. Yes, if they ask multiple iteration, yeah, we can take values from this. But they haven't mentioned the number of iterations. So okay, here it means t plus 1 meaning only one iteration. No?
Right.
They say
The problem
at
they
t plus 1.
formulated as t at t and then t plus 1. Yeah,
In
these are
case they give it as t plus 2, is it second iteration? Is that?
yeah, that's the trickier part they are doing in the questions actually. But Samishwara, he can correct
So
us.
theta 0 is a complete vector, right? I mean 0, 0, 0 they have given. So
Right. These are the initial values of this is theta 0, theta 1, theta 2. I think this might be misleading, theta
Yeah,
not. That is
hmm.
actually,
could be a superscript.
Or should we call them what is in the vector is W0, W1, W2 or something like that? Weights
yeah,
and
it could be like W. And then after first iteration, these are the values of theta.
And one small catch is in the gradient descent, theta naught alone, we won't apply regularization. It's a formula only. Uh, Other theta
Oh, okay.
apply the regularization.
Oh, okay, sure, sure. Do you want to cover L1 regularization? It's a different formula, right? Even here, theta naught uh, is no modification. Yeah. Okay.
L1 or L2 will be specified in the question, right?
Yeah, it is. In this question, they have mentioned what will be the values of theta naught, theta 1, and theta 2 at t plus 1, given the alpha rate, and L2 regularization constant.
Sometimes they may use the name. Lasso is L1, I think. Lasso and ridge. This is ridge. They can say L1 or they can say lasso. They can say L2 or ridge. Ridge regularization.
Okay.
so we have to change actually if they ask reach and all in the code.
Yeah,
No,
here, uh, yeah, maybe let me explain. This one, input 248, right?
Mm.
We can run here. If we are running from here, click on run here. This is L1.
L1. Okay, okay. This is L1. Okay.
L1. And here they have given the number of iterations. And x1 and x2 we have to give, and also y.
Yeah. Okay.
Okay, got it. Yeah. And then
So how are the x's and y given in the question? Can we have a small look?
yes. In this
In
particular
this
question,
question,
yeah,
No,
go ahead.
here directly they have not given. They specified AND gate. So we have to write truth table for AND gate actually.
Yeah.
0, 1, 0, 0.
Yeah, x1, x2 are the inputs to AND gate. Y is the output. If both are 1, output will be 1. Remaining is
But there gradient descent is mentioned, right? Gradient descent optimization algorithm. So why we are looking at logistic regression there means
no, it is a gradient descent for logistic.
logistic regression. Okay.
Yeah. This is the
And the
cost.
question only we are given. Interesting.
Yeah, for cost and loss functions, we use the gradient descent approach, both for logistic regression and linear regression. Anything, but only thing is the cost functions and loss functions are different
Change actually.
for both of them. Yeah. So the approach is same to find out loss and entropy and others.
Okay.
Okay.
So, so what does it mean by regularization here? Like, so, I mean, just submitting the previous iteration result into the next iteration, is it?
Actually, what happens is when we take the approximation for the next step, right? So basically, we might get a large values of theta. Okay.
Okay.
So and that will not be suitable for the final model. And if we get a large values, right, lambda will compensate or penalize the old values of old iteration theta. Okay, we want to keep theta values to be as minimum as possible. Like if you say some 10,000, 20,000, 30,000, and all, if you get for theta, right? So the
Okay.
model will be overfit or underfit.
Okay.
Okay, so that is why we introduce the term called lambda, which will bring up the total value in the final value, and then the previous iteration we feel it is not good and try to regularize in the next iteration. So that is how the theta values will stabilize after some time.
Okay. So, but the learning rate would control these kind of overfitting, right? So we can put some very less learning rate.
Yeah,
So, but
learning rate is also key, correct? Yes, learning rate also we need to choose a proper value.
yeah, I see learning rate alpha in the formula, but I'm not getting what indicates regularization in the formula.
Satish, I think learning rate is not only the parameter which help us to reduce the overfitting.
Okay.
So basically in a gradient, we follow the concept of convex. Learning rate help us to find out the local, or you could say the minima point or maxima point.
No, it will the rate at which we reach to local minima increases or decreases actually by properly choosing the learning rate.
Yes.
It
Okay.
will take lot of time actually. If you choose wrong learning rate, it will take lot of time to reach to your local minima actually. So appropriately, you have to actually choose this parameter. These are all the control parameters where the programmer has the flexibility actually while training the model.
Okay. Okay.
So by choosing properly this one, convergence will happen fast actually. Your loss becomes quicker way. Means you reach to your local minima faster way actually. Or otherwise, it will take slow steps if you give less learning rate actually.
Got it. Yeah. Thanks. But regularization, like just in
Yeah.
formula, which parameter indicates the
Last
regularization?
one. Last one. In the
Lambda.
J
Lambda
theta.
is norm. Whatever norm we use. Lambda is the regularization coefficient or what
Go
factor.
to
Okay.
this last. No, J theta. This one. Yeah. This lambda by 2 to n theta j square is there. Na? This is the
Okay.
regularization.
Okay. Perfect. Yeah. Thank you. Yeah.
So before to that, actually, this is the cost function. And here we are penalizing actually. Okay.
Makes sense. Yeah. Thank you.
So how to identify where to apply cost function, where to apply loss function?
Cost functions and loss functions are how well our model is converging, right?
Mm.
So it will be there by default in every model. So that is how we arrive at a final good theta values.
So
This sorry, go on.
so what I understood is that loss function is the every iteration level cost, and cost function is the consolidated loss we have in that iteration. That's what I understood. Um, so both are same, but if you consolidate all these loss functions, that will give you the cost function of the entire model. Yeah, go ahead. Yeah, that's just
Yeah. Yeah. Correct. Correct.
theory part. Yeah.
Where is that parameter for lambda? I didn't see that, or is that?
Given learning rate is given. Yes.
Okay, okay, it is there. Sorry, missed that.
Okay.
If you have
Do
any
you have any other questions?
number
So
of
if I'm using lambda, sorry, regulation type is L2. So L2 means it might be the square, not mean square. Sorry.
Yeah. Square. Theta j square.
Yeah, but yeah, okay. Okay, no sure. Hmm. But now I think in the cost function we define only lambda. Theta j. Okay, ठीक है. No, yeah, got it.
Any other test data we have?
No, it
So
generalizes all the logistic regression problems, whatever code is there, Sumils code. Is it a generic implementation? By simply changing the values, can we get solutions for all the problems?
yeah, that's what my next two input it is given. If by any chance if our if we have three inputs, three parameters, three attributes, x1, x2, x3.
Yeah, simply can we change the code or any
That's I'm not
specific
sure.
implementation to this problem?
I think it's generic only. Yes.
Generic only.
Yeah, yeah. So in the code, I saw that x0 was added in the code only. So he added like insert x0, and the x values he's doing on the -1 data self log.
That's what from a problem question to this where to change and all. Will it take time?
No, no. Here and all, no changes required. Only in this line, right? Let's say L2 only we modified. For L2, in this here, we have to give the parameters x2, sorry, x1, x2, y, and then modify the alpha and lambda. Okay, this is for linear regression. One second. Let me go back. So here, let me try to add x2. Is that okay?
Yeah.
Sorry, x3.
I think you need to put one comma there.
Comma.
So for logistic regression, all the things are there.
In it we have to modify.
Sorry, where?
I think it is only designed to take only two input, x1, x2.
Okay. Yeah, that's
Yeah.
it.
That problem you may have to change actually.
Yeah, it's able to print x3, but
Like if there were two parameters, then there was theta 0, 1 and 2. So if there are three variables, then there should be a
oh,
theta.
no. Wait, let me try again. Makes sense.
Yeah.
Oh yeah, thank you so much.
It's working. Okay.
So since
Mhm.
I joined late, I just wanted to confirm. So the code will work by just changing the inputs.
Yeah, right. Yeah.
So just
Why?
now I noticed, suppose if they ask like lasso and ridge in place of L1 and L2, uh, uh, they is already in the main code itself. Can you scroll above?
Correct. This one is L2. This is L1.
No, can you go to the main code? Main code at the bottom. Yes, here, just below. Here, yes, here. He has already self-regulating L1 or lasso, then L2 or ridge. No, below. Scroll below. Yes, at the
Oh,
bottom.
okay.
Yes. So we can pass lasso or ridge in any of the functions. It will still work.
Right.
Yeah, but as long as we know what is what, right? I mean, we can just pass L1, L2. So,
Yeah, in case of any confusion, we can just refer this code itself.
Right. Okay. Even for logistics. Cool. So yeah, he has linear regression without
Ah,
regularization.
yes. So this was my
Linear
next
regression.
question. How are they gonna ask without regularization? Like, will they mention like there won't be any regularization, or we should
Yeah, I think like Shankar mentioned, right? So the first part is without like regularization because they didn't mention anything. What will be the value of the loss function at t? So
okay. So if they
I
did
think
not
by
mention any
default it is
regularization,
without.
it is without.
yeah, we need
Okay.
regularization constant and learning rate both for when we in the question it will be given.
Okay.
Here initial values also we can change. Suppose here is 0, 0, 0. That's why we are getting 0.5, 0.5 and all. So we can change that initial values in the code.
Which value?
Initial values of theta 0, theta 1, theta 2.
Yeah, yeah, yeah. This is with theta underscore init, this parameter, right?
So for calculating the loss, we simply said lambda is 0, right?
No, lambda
No, not
they have given.
lambda.
Lambda they have
Lambda
given.
is 1. Theta underscore init, right? This is theta 1, theta
No,
2,
like we were
theta.
seeing that in that first part, we simply had to calculate the loss function. So we can calculate the loss function by setting lambda 0.
No, we are not using lambda.
Loss function.
In that scenario, we are not using the regularization terms. If you see the code of cross entropy loss, and could you scroll down? So the
Yeah.
last line, that is plus lambda by 2m. So it's missing in the upper one. So you are not using that regularization part in that term. So you are not using any lambda 0, anything else. You are not pass the value of lambda or that regularization part. So it's an additional part. Normally it's used when you're using that regularization part. So just compare
Right.
between
So
that equation and the below equation.
right, for the first part, right? For the first part, cross entropy, you have to run this one, logistic regression without
Okay,
regularization. Lambda is not needed, right?
okay.
And then get the loss function. And that's for A. And for B is the next other code.
What does T and T plus T mean in the question? At T.
Sorry, I didn't get that.
Like at T and T plus 1. What is the.
Iteration actually.
It's just
Number of
iteration, huh? Okay.
basically first iteration.
If it is T, just T means
He,
T. Yeah, they've given the initial values at T. So they want to find the values for T plus 1. So assuming that, this is the first iteration, T plus 1. So yeah, here they've given value only for first iteration. After first iteration, what's the value? So value T plus 1.
So it is full implementation for logistic regression. In that, whatever may be the question we get.
Linear is also there.
Yeah.
Yes,
Yeah.
given for
Whatever
linear regression with L1.
Yeah, that will come to the For logistic thing, that is full-fledged actually. Whatever they ask in our exam, we can attempt it. We can use this implementation.
Correct. Yeah, just that this table has to be written.
Means nothing
Why
more
not?
they can ask, no? Means not more than this with respect to logistic regression.
Hopefully. No, there's another, this is for gradient descent specifically.
Yeah, gradient descent is there and coefficient theta also we are finding. Yeah, I think it is there.
All right. Any other sample? Okay, this is for gradient descent.
That's what
For
any other sample is there on logistic regression or question papers.
I think this data is sufficient to validate this program, gradient descent. Right, I think you have also calculated with the X3, so which is also good. Decision tree, does anyone want to try this?
Excuse me. Actually, I hear some echo. I'm not sure if it is for everyone or only for me.
Yeah, we hear it.
Yeah.
Okay.
So is there a way to change the cost, the function, in case they are giving a different function, and we want to apply the cost function based on that h of 0 is different, or maybe the cost function is different.
For this one, J of theta.
Yeah.
I don't think that will be different, right? Or
No,
will
there
be
can be.
separate?
There was a case question that they had faced where they modified the cost function and then based on the cost function calculate the linear regression.
Yeah, in case
So
of
we may
logistic
have to
regression,
go to.
h of x is same.
Yeah, here itself they have added a w.
Yeah, that's right. That's possible. Yeah.
Yeah, but here I think they're looking more of a derivation. Right. No, they've not given values.
No, in the
Deriving
logistic
values.
regression, h theta of x will not change actually. In case of linear regression, they can hypothesis can change.
No, but in any case, so x to x3 values are in the hypothesis itself, right? When we are dealing with loss and functions, it doesn't matter. But
There
this
is an
kind of
echo.
question
Let
is
me
given.
try.
Yes, actually, it's coming from Hindu. Kolhapur Hindu.
Yeah, I'm actually yeah.
Okay, so in case the loss function is changed, loss function is changed, loss or cost, sorry, cost function. In case the cost function is changed, can we somehow modify it in the main code? Just let's take that this example itself, where they modified the cost function. How can we incorporate it in the code?
It's same only. That's what actually cost function is same for linear regression. Only that h theta of x, that hypothesis will change actually. What function they'll give, that we have to use actually. See, in case of logistic regression, it is always sigmoid actually. But in case of linear regression, this hypothesis they can change. They can give any function actually. Suppose e power x minus mu, like that they can give any function. So, is there any provision to change here only? We are linear regression implementation. Samba, can you add? We have in sample papers a few examples actually where different hypothesis functions are given.
Yeah, so what I am saying is this code is dealing with finding out the cost and loss, right? So that it doesn't matter because they will give x1, x2, x3 values, and based on that we need to calculate the cost. So
No, but the point is that x1, x2 we have to substitute in hypothesis no to get the predicted value.
For linear regression, correct. Yeah.
That's what I'm saying. Yeah.
This one, here h theta of x is equal to theta transpose of x. So you're saying this might change, right? For linear.
So meaning is it hard coded then? The h of x
I
in the code?
believe so. I think it must be.
Yeah, maybe we can search it. Theta power t.
Where is it printing? Just give me a moment.
If you go to that linear, if you scroll down, little further scroll down, there is a function for linear regression. This is logistic. If you scroll down, there is a function.
So if you enable the line number and line number 161, that's what I see.
Yeah. Next actually, if you this is loss. If you scroll,
Run linear.
yeah.
Press L, you will get line number.
Sorry.
Escape it, yeah.
Which line number?
161. Yeah.
It's 173 exactly. If you want, what is the H calculator, right? 173. Can you go to the 173?
Oh,
This
okay.
is
Yeah.
this is
Where do they take the transpose? I'm not sure. Here, right? X H. And then they transpose.
it's a dot product. In general, it's a dot product of x vector and theta vector. That's why we get theta naught plus theta 1x plus theta 2x2.
Oh, okay.
Right. So it's in the matrix or this terminology, it's theta transpose x.
Okay. So where is the dot product? Sorry, which line number?
173 only they will be doing.
173. Okay. This at symbol is dot product.
That I don't know. That
Yeah, hopefully,
that's the
they
line
don't.
hypothesis is applied.
Right. Will we go to the next program, the other Python program?
So for this modified linear regression in the example, how do we change over here? That I have not understood.
See, at least in the sample questions, do you have a sample question for that, for the test data? think this modified loss function, okay, this is a modified loss function, not the hypothesis. I think here, if at all hypothesis changing, this is where we have to change. But, this needs, but yeah, if we have something to replace and see some other example functions, we can try. Right.
If it is modified loss function and still you want to calculate, I think in the linear regression loss function, right, 183 line number, that function, you may need to apply weight factors if you have a weight vector with you.
Okay, got that.
When your modified loss function is given and you know which other extra thing to be modified, that's 188. Without regularization, 188, etc. But the question that is given with modified loss function is to derive the, theta updater, or
I
they are
think
asking,
it's estimating the value of the weights.
right? So they are asking us to estimate. So we need to
Derive the equation to find the value of loss function. That is the first part. There we need to actually do it.
Right here, if modified loss function is given, right? Okay. Right. The naive base, did anyone happen to verify the code? Can we go to naive base or the decision tree?
Yeah,
In the interest of time.
we can go to naive base. Not sure I. Oh, someone else talking.
Yeah. I verified my base with multiple examples. So it has 3 different flavors. One text classification, non-text classification, text with Bernoulli, and multinomial.
Okay. Naive base.
So we just need to plug in the value. So
I have not gone through this. Does anyone want to explain? So this question, what will be the question? Multinomial. So
we will be given the text and classify spam or ham, or yes or no kind of things will come.
Okay.
So we need to just place the text there, and parallel to it, there will be a table kind of thing will be given, or they will say, okay, this text is spam and this text is ham. Spam means, yes needs to be replaced with spam, no needs to be replaced with ham. So finally, it will classify yes or no. So this is just model fitting. Okay, so you need to give input all the text,
sure,
yes or no, and
yeah, these will be given, right? So there is one text, two, text three, text four.
Yeah, this is just a model fitting. Below, if you go, there is a predict. So you need to give the text there. It will tell whether or not it is spam or not, ham, or yes or no kind of classification. Yeah, this one, line number 139. So this is just a simple text. It will use the data given in the fit model, and then finally it will predict here.
So some here. One small question. So Laplace smoothing is by default we apply, right, in the text?
Yes, correct. So that Laplace smoothing also depends on whether you are going for a Bernoulli or multinomial. So that we need to carefully give it. So if you see in the fit, right, so model equal to multi is a multinomial, and the Bernoulli is single, right? So you need to give Bernoulli or multi. So that will be specified in the question, or else we need to write for bag of votes we are using the Bernoulli or multinomial. If they don't give it, so if they clearly specify it is multinomial, model equal to multi you have to give.
So if nothing is specified, then which model should we use?
Okay,
Depends.
that depends. So for bag of vote means text kind of classification. We can use Bernoulli or multi. Okay, so if they ask us to choose, let's say specific to the industry, right? So some places where word is present or not in the document only is important. Frequency is not important. There we need to use Bernoulli. Okay. So for
So
example, say,
if frequency is not important, then we use Bernoulli.
yeah. So basically, let's say take a case where um, you are taking so many people data, and in spite of that data being repeated in the document, we just need one occurrence whether it is there or not. That kind of scenario we need to use Bernoulli. Okay, but in the email classification and or spam kind of classification, right? Both are valid. Bernoulli is valid and also multinomial is valid. Okay, that we can just mention in the assumption. But if the question says that uh, some medical related things when they come, so only yes or no is important. So for example, if one word is there, cancer, yes or no, BP is there, yes or no, that kind of things, right? Irrespective of BP is being repeated multiple times in the document, we just need to consider only one. So there we have to definitely go for Bernoulli. Okay,
Okay,
so
thanks.
that is the only decision we have to make. Yeah, this is about text classification. If you go below, there is one more where this regular conditional probability we take. Yeah, this question. So yeah, so
I
here,
think we have a chance to pass now that I have joined this meeting.
yeah, so here actually, I think it's automatically taken care. So there are two things. One, if you get some numbers right, so the numbers are generally
Okay.
continuous variables. So we need to use mean, variance, that kind of thing. If you just have categorical variables, you just need to find the conditional probability. That means how many times yeses come, how many times no's come, and all. So finally, it will predict yes or no. So if you just come down to the last, so how we will give it? Initially, we will give a table, and we select few parameters from the table and ask what is the probability. So like if you see 135, right? That's the input data. Come down a little more. Yeah. So this is the input data. So where there will be table given 4.5 male pass, 7 female pass, 2 male fail, something like that, right? And if you come down, how we predict is actually the below. There is a predict still more. Yeah, we will
Yeah,
be
this
given.
corresponds to the simple question, right? If we want start this
Yeah,
question, no?
exactly. Yeah. Yeah. So if you see the question, they will ask study hours 3.5 male, whether pass or fail. So here study hours is continuous variable, right? So in place of that, they can just give something else like um, subjects. They can give maths, so on and so forth. And then they will ask, okay, whether subject is this and gender is this, whether they will pass or fail, something like that. So the second example is the categorical. This is the when some numbers come like 4.57 and all, that will be a continuous variable. So their mean and variance will come into picture.
So when it is categorical, then at that time what we will use? So if there is a subject and then gender,
Yeah.
so in that case, what we will use?
All categorical. The only thing is you will not see
Mhm.
mean and variance calculation. So we will just see that subject conditional probability, and then finally we calculate. From the program perspective, you don't need to worry. I'm just explaining the concept. So you just need to feed in the data in the program. It will automatically take care.
Okay.
When I was trying these questions with normal Excel calculations, then my answers were differing in decimals or something. So when you tried out with the notebook, then did the answers match exactly?
Yeah, no. For this question, actually, whatever is shared in the paper is wrong. So mean and variance are varying a lot.
Yes. Okay.
Yes.
So even that means might be the solution is not perfectly correct.
Solution is
Solution
completely
given by the
incorrect.
faculty.
Yeah, it's completely incorrect actually. If you see the variance below 6.4 and 3.7, right? So mean and variance, that is way different in here. Yeah.
Yes.
So
Yes.
at least in the first column, somewhat they are okay, but the failed class, it is completely different.
Oh yeah, actually I calculated and I got wrong. Then I felt like I'm doing wrong in the basic fundamentals.
No. This is correct. So,
What is this answer for variance by the code?
sorry, variance. What did you ask?
The variance, yes. So using this, we calculated 6.433 and 3.7. So actually, I have my Excel open. So okay, so my values were correct. Okay.
Correct. Yeah.
Hmm.
You
Chalo,
would have
thank
used
you.
standard Excel formulas, right? Yeah. So this is correct. What is there in this program is correct.
Because we tried all the time with Excel population, sample, or none of the formulas would match the answer given there.
Yeah. So somewhat if decimals are varying is okay, but the answer is too different. So then how come it was shared to us that this is correct? Yeah.
So,
But anyway, it will
quick,
depend on this.
quick question. So, do we have to use sample or population here, like in terms of calculating this mean and variance?
It's a population, everything we consider.
No, this was sample data set,
Sample,
right?
right?
I think that there was a
No.
question
Don't
on
worry about
WhatsApp.
that term. Sample data set means it's a complete data set for us. So you don't need
Okay,
to worry of that statistics terms, so sample variance and population variance. So if you consider this is the whole data, what we calculate is the population variance.
okay.
Yeah.
Thank you.
Yeah. So you just understand that as an example data set. So don't worry about the word sample.
And may know whomever did it in Excel, right? What was the formula for variance you used? Variance dot P. I mean population or sample. I mean, just to match it here. Yeah.
So in Excel also somebody was saying same on.
Yeah, in Excel it is yeah, different formulas are there for sample and population.
But how do you
Yeah,
give sample or population? So we need to choose some of the samples from the existing data set and then give as a sample, right?
Correct. Actually,
No,
I don't need to
formula
worry
will
about
be divided by n or n minus 1.
that minus one is only it's for sample, right? That's for
Right.
population, just simply take n. That's it.
Okay. Sure. If you want, we can check here how he has implemented the
This is
variance.
NumPy formula, I think. Direct NumPy formula are there.
Oh, okay.
I have one basic question in this example. How did he get this value for probability of study hours 3.5 given y equals fail? How did he calculate that?
Uh,
Last at the end.
we use yeah, there is a formula given here. So we treat this as a normal distribution, right? For normal distribution, we need to calculate the mean and variance, and yes, x value we need to change in the formula. If you can go up a little bit, yeah. If you see the x, right, in e power x minus mu whole square.
Yeah.
So that x is 3.5. Mean and variance is the total data set mean variance.
Okay, he has used that formula to get that probability.
Yeah, correct, correct.
Okay.
Yeah, just now when discussing, I had gotten this doubt. So when we are calculating the mean and variance, okay, in this program we should have used just stats dot variance or something like that. So
No,
mm,
one other basic question. Now, if we get a question of this sort, we just enter the inputs here, we get the output, and we just copy this output, right? So, is it fine in the sense everyone will have the same output?
yeah, so
Yeah, answer has to be the same, right? But
The same
Steps will be
output
the
is
same.
better than no output, right?
No, the steps also will be the same, no? So won't they get suspicious?
We have to add some prefixes and suffixes.
Yeah, variable name change. Anyway, our handwriting will
yeah,
change.
Obviously
if
will
I
change.
get 1 mark for this formula only, then yeah, it should be.
And sometimes you may choose, I mean, again, for simple computations, we may use Chat GPT
no, no, no,
for
no.
equations and all.
ChatGPT, I saw it is doing mistakes for this normal calculation.
Is it actually?
Yeah,
But
yeah.
for
Don't trust that. Even addition and subtraction, it is actually giving mistakes.
The
no, we
problem
have to.
is
We
not
should be
following the.
little brackets and all. Actually, the braces and all.
Yeah, you need
It
to
should
give proper
be.
framework.
We should correct. Correct. We have to give properly. Uh, and it's not for that, but for if you wanted to add any description and all for some explanation and all. For that, I think we can take input from that.
Right. Chat GPT, don't trust the numbers because I found out that the normal multiplication calculation and the result was completely off. Uh,
I tried for some calculations, but it's working good. Of course, yeah, it's throwing some errors also. Sometimes it's, yeah, it's giving errors.
Someone mentioned this value, right, is in the table. Is it in the binomial probabilities? Does anyone recall, in that case? Okay. But anyway, we can trust this program. Uh, Anyone knows someone with. Anyway,
You mean three flavors of formula, right? Sigma square, outside and inside root. Is that what you're
no,
searching for?
not that actually. We can find the values of that probability directly from the table, like
No, that is
Z
for
square.
categorical variables. Revathy. So the class conditional frequency, right? So study
Uh-huh.
hours is a continuous. So we need to apply some PDF based on its distribution. In this case, Gaussian distribution. But in case of the gender, right?
Mhm.
The class conditional frequency, you will get it from the table only. So we need,
Oh, okay, okay.
yeah, this one.
Hi, have you guys discussed the logistical regression already? I just joined late, I guess.
Yes, we just finished and switched to nearby.
Okay. I had a specific question if you could answer. So in the sample there is a question and they say that's modified logical regression. That doesn't seem to be covered by this code, right? Or am I missing something?
Yeah, it is not covered. So you need to change the
That's
formula
right.
there in the code.
Okay. And same for the sigmoid function also, where we have to change it somehow.
Yeah, I think sigmoid function changing is difficult. At least for the linear regression, you can change because it's already considering some existing libraries for the sigmoid, I think.
Right.
Yeah. So logistic regression, I'm not sure if we can really change, but Yeah, other things like linear regression, you have a chance. You can change.
Okay. And the Excel that was shared, it contains that answer to that question. So can we rely on that if we get similar question?
Yeah, I didn't try Excel. Yeah, maybe paste it. We can try it. Rely on it.
Can you share that Excel?
Okay. Shall I share here?
Which question?
It was
Ah,
shared in
yes.
the group only.
Yeah, same group. Can you please reshare?
Okay.
Again that Excel from Sumil, right?
I'm not sure who shared it, but
Okay.
Maybe from Sunil Mittal, right? At the previous meeting.
Yeah, he shared.
But now we are discussing on this one, no? Even this is.
yes, this one, right. Exactly. So if you see this sigmoid function is somewhat different uh, as compared to the normal one. It contains x1 square and then plus minus also are different somewhat. So just let me share the Excel.
Isn't it?
Okay.
I think it also
Here,
obtained by calculating the x values because still it's a sigmoid function and we need to input it the thetas or w's and x values. Pre-compute those values and we can pass it. I'm just thinking it's still possible. We no need to
In
modify anything, but the
here in the 74, they're sending values for a sigmoid.
actually in this sigmoid we are passing the whole uh, x cell dot x, and but we somehow need to change it.
no, we no need to change the function, Gaurav. What my understanding is the W0, W1, W2, right?
Hmm.
So those values uh, we can pass accordingly.
No. So
There's also square on X1.
in the program, what it will do is it will do theta transpose x. Okay, it's just a simple multiplication.
Right.
So here, so if you see W0, we don't need to multiply anything with, right? So
It is fixed.
yeah,
I shared the Excel. If you can open that, I think at least values at least match um, to the sheet, the solution provided. Yeah, this logistic one. So they are this multiplying C6 two times. If you look at C6 is actually the x1. X1 is being multiplied two times to make it square, and then they are also obeying this minus in the middle of the sigmoid equation.
So what is B2? B2 is W0.
P2 is yes W0.
B2 is W1. But here the formula
I think
is
you
plus
have to
W1, right? Plus W1 x squared, but here it is minus
Yeah, it's the
W1.
minus. There's a whole minus before this. Like in general, it's exponential of minus of the whole function, right? So the
Oh,
whole
okay.
minus is in the front, and then they are.
Okay.
you have to enable editing, right?
This is W1 x1 squared minus W2 X2.
So this again one question. The question that I had in the question, it was mentioned that it's modified logistic regression, and the result of that is in the calculation we are not considering the sum. We are considering the individual values of this h naught, at y naught minus y. Only then these values were matching.
Sorry, come again, Gaurav. Which one
Yeah,
you are
if you look at just scroll down in the Excel sheet, please. So this I naught I1 value, the W naught of this B16. If you look at the formula for B16, yeah. So here the G6 was used to multiply. Normally for gradient descent, we multiply by the sum of all these h minus y values, right? But here the individual value was considered, and the n was taken as 1 only. If you see, like B12 is taken and it is 1, and G6 is taken instead of G12. G12 is sum, but G6 is the individual value. This is how the values match with the solution provided by faculty, but I'm not sure if this is correct or not. Like it's not what was taught to us, I think. So they say these three iterations are, and this if you look at these cumulative values, and then they're accumulating these values like on top of by adding to previous, like K6 to KM6 columns. These are, and then in the next row there are these cumulative values that are being used for the next iteration. Like, looks like I'm not sure if I have, like I did not find in the lectures or videos that they taught about this modified something, but this is totally different way of calculating.
But for the third iteration, it is then it is cumulative. Huh?
Somehow these KLM values are also being used in the formula.
I think, not sure.
Is it mentioned in the question by any chance? Because yeah, I remember Sumil was mentioning
Yeah.
uh, he referred so many things and then he figured it out.
So you say it's three iteration of modified gradient descent algorithm where gradient update happens after every training example. So I think that's what's
Yeah, that's
being,
the key. Yeah, that's
that's
the
the
key.
key. And
Yeah.
that's the key, and I think that's why it's being cumulated, and then n is taken as 1. That's it. So maybe we can refer this Excel if we get some similar, and for normal we can refer the code, right? I think this was exactly my question.
Yeah, yes. So either we modify the code or use this.
I mean, we would have no time, so I think we can.
Right.
I shared, like everyone has
No,
this
no. If it is
Excel also, so
completely different, right? Then I don't know. So
yeah, it'll take time, I think.
here also, I mean, if it is just like how it is given there, it's okay. But if they give some plus or something on e power, right? So then this also needs modification.
Yes, this will also take time. During exam, we'll have to just struggle with the formulas and all.
Yeah.
Yeah, thanks for pointing out. Yeah. Okay.
Yep, yep.
What is this for you? For this K?
this first
This
first
one.
line is first line is fine. If you look at the second row, then you would know that it's cumulating the values actually
So
from
what is first
G6
previous.
line?
and G7. This one
First
is
line
not
is
formed.
no, I think it's exactly the same value if you just do the
Oh,
rounding
okay.
by 4 for all these
Uh-huh.
values.
Like same as G6, right?
Exactly
G6,
right.
H6. Okay, okay.
Hmm.
I6.
Yeah, yeah. If you round by 4 of all these values, you'll see it's exactly same.
Right. Right.
Okay, thank you guys. I think sorry if you want to continue. Sorry, I just
I think, yeah.
No, no, yeah.
It's okay. Yeah.
This is good. Okay. The confusion matrix.
yeah.
Yeah,
And
I think you've already.
if you
Can you
like,
explain this also?
I followed the whole answer in the word only. So now what next they do? So if you just scroll up, please. So these three value, the one highlighted with yellow, these three values can be found in the sheet also, but the other way around in the transpose way, like I1, I2, I3, and then using these three values, the predicted y is found here like 0.05. I can share the sheet that I have. I just calculated these value as well in the sheet only. um, so these values are
Sure.
okay.
Can
I'll
you
just
share? I think
forward
you can
you.
open that.
Okay, let me share now then. I'll have to open WhatsApp on the laptops. Just bear with me. Okay, can you check? I just shared. So this HX in the O column. So it's like applying this same formula using these I3
Modified.
values, I3 values now. That's all. And then based on that, Y is predicted if it is more than zero point 0.5, then 1, otherwise 0.
Okay.
And then using these values, confusion matrix was made.
So when they say learning rate 0.5, that is the threshold we have to take.
I'm not sure. I think I just consider that no, but this learning rate is different. It's the alpha value of this function,
Right.
sigmoid function. No, so of this
Okay,
Gaussian.
yeah.
Yeah. But I
So, but by default, we can take the threshold as 0.5. Is it?
yes, yes. For these all the classification problems, we can consider zero point 0.5 by default.
Any questions from anyone on this logistic regression modified?
So the code that Sumil shared and this both will have the same solution.
No, no. Sumil, right? Yeah, Sumil's one is not having the modified one. It is using the default sigmoid where the dot product, right? We are just sending the dot product for a z value. So when there is a question with the modified function, a modified sigmoid function, we have to use this Excel sheet.
It's only for logistic regression only, right?
Yes.
The change. Yeah, yeah.
So in that case, we cannot consider 0.5 as the value. We
Correct.
have
We can try. We can for classification. We can take the equal to or less than. Maybe we can say no or
first,
maybe
yeah,
yeah.
confidence matrix will go down. We may have to calculate the, I think, a modified matrix.
Yeah, this is the
This
calculated one.
is
Y hat. I think
this
it's
is y
Y
hat,
hat.
right?
Yes,
Yes.
yes. Y hat actually. Yes.
Yeah, this is y and this is y hat.
Can you reshare once it is completely updated? The section sheet.
I
Yeah, only
shared
this
only this
is
change is there. The rest I shared already.
Okay.
only this one P column is y hat.
Okay.
And the confusion matrix. So when so this one will be y0 and yeah, like this, right? Y0, y. So this is predicted. This one will be y hat, like that, if at all.
That's
So
correct.
when y hat is 0 and y is 0, we'll count it here. When y is 1 and yeah, y hat is 0 or 1, we'll count it here. Okay. Here, confusion matrix we have to write, yeah, do it on here, do it on our own. The question is what? Okay, confusion matrix is the output they want. Right. So this is a gradient descent Excel, but I think we can very well use Sumils, right? We need not go through this sheet. Yeah, I think this Excel was a good one for logistic modified. Even if there is some modifications, we have to modify it in this formula. Right? Okay. And I'm sure these questions will not come. Okay.
Right.
Can you come again? When should we use this Excel and when should we use Sumils?
See here, this is a modified gradient descent algorithm. Oh no, not this one. This is a hypothesis function for logistic regression. Only is changed. By default, right, in the Sumils program, if you see, the hypothesis function is 1 by 1 plus e to the power of minus theta transpose x. That's the default one. Okay. Here it is e to the power of the weights are added this way, where there is an expired weight.
Actually, we could have used Sumils only with modifying our new x1 as x1 square. We could have done that way also. Like
Yeah,
our new x1 could have been his minus x1 square kind of.
yeah, that may be more appropriate.
Sorry, what?
Like we
And also
compare it
this
to the
section, no.
standard function and we change our values and variables according to that.
I initially thought that money, right?
Yes.
Inputs if we pass to to match to the function. I mean, like
Yes.
W0, W1, W2 is 111.
Yes.
Whereas inputs we can pass minus x square,
Hmm.
but we have not validated it, right? So that's only
Okay.
the.
Okay.
And one more difference is also there. I mean, that formula will not fit because it's not only the function changed, they asked its cumulative way. Usually we take the sum when we are calculating the gradient update, sum of all inputs multiplied with that update rate. Here, they said update happens after every training example. So there is a cumulative. First sample is taking only one. It's not some doing the sum. That's also a change.
Okay. Okay. So the normal gradient descent will consider everything, while here that it is specified this way, so it will not work out.
Yeah. So two updates.
Actually, three modes of update actually. Batch mode and what is
Hmm.
that? Mini batch mode and the
Mini batch. Yes.
stochastic.
Stochastic.
Yeah, these three if we implemented. This is single instance case actually. Means this is a stochastic implementation. For uh, every time we have to update it actually. This comes under stochastic gradient update.
Okay.
So that those three implementations, yeah, it is not there. I think it is there. We can appropriately use.
Do we need to validate this bag of words multinomial with a example, the solved example, or is it okay? Do we have any examples in the slides?
I will. Sambashura, he validated. He said two, three examples he validated. I only validated the one that is given.
Yeah, so I validated from different papers. So there was a small catch, like one extra word it is considering under spam. Okay, so yeah, so that's the only difference, and otherwise it's fine. Like here, if you see 1/48 or something, it will take. So it is supposed to be 47. Okay, so this is different example, right? So I validated some other example
Sure.
where ham spam things are there, right? So that one I have validated.
Okay, so we'll get 1 mark less than you, if that's okay for us. Um, so okay, yeah. There was which one, like multinomial or Bernoulli, like that?
Bernoulli, multinomial,
Okay.
two things in a bag of words. This is called a bag of words approach. And the below is the posterior probability. The below last one.
Mhm.
No. The last one. Like
Yeah, that's the categorical, right?
yeah,
Categorized data. Okay.
yeah, yeah. Hopefully they
So,
won't deviate from this kind of questions. I mean, they won't put any condition or something like that. So otherwise, will be. So only thing is the if they ask do the stemming and lemmatization, then we will be in trouble. So that is not taken care here.
So here we have one or two features, right? So in case if we have multiple features, then we have to add one more array, and then we have to just pass it on, right? That should work out.
Correct. Yes, you need to add. You can add as many texts as possible. So only thing is if they ask you to do the stemming and lemmatization, right? So basically, let's say Chinese Beijing Chinese space, A, D, those kind of words come, we need to do the stemming. So we
Okay.
have to be intelligent enough to pass the proper input to this function, then it will work. I mean, that stemming we have to do outside of this program. So then it will start working.
Got it.
Hopefully they won't give it, but if they give, we have to do that.
And also, like, if they are not providing yes or no, and in place of that they are providing plus or minus or 0 and 1, then still
Yeah, it
we
will
have to
still
tweak a
work.
bit, right?
Yeah, it will still work. You just need to pass plus minus.
Yeah, yeah.
Whatever is given here, it will take. That's it. It will have.
Oh, not
So
just
it
boolean yes or no, it will take plus or minus
will
as
take
well.
anything. It is just about um, number of output class variables. That's So you can have 3 classes, 4 classes. It's up to you.
Yeah, that I can, but the classification, the target, it's not just boolean, right? There's a chance that we can get plus or minus or 0 and 1s as well.
Yeah, you just need to pass that in place of S and no. You need to plus minus.
Oh,
If you
that
find,
will work out still.
yeah, it will.
Oh, perfect. Yeah, thank you.
Alright. Do you want to look at the decision tree? Yes. Yeah, this was pretty long. Yeah, here he validated with the 2 data sets. Looks like income, education, gender, and this one is play tennis. We're finding the Gini index. So he has found Gini index for each of the feature, right? X, x1, x2. And minimum Gini index is for outlook. So finding the minimum Gini index. And then entropy, information gain ratio. Here entropy of S is found. Then entropy for outlook equal to sunny. And then outlook equal to rainy. Outlook equal to overcast. And here the average information of the outlook. And then this, the information gain is entropy of S minus average information, and the split info of outlook. How does it know that? For each of the values, -5 by total number of the rows, -5 by 14 log to the power log of 5 by 14, like that. This here for sunny it is 5, 5, and it is 4. And then the gain ratio is information gain divided by spread info. And then the next attribute is temperature. And then yeah, finding values for temperature. attribute is humidity, finding values for humidity, and then windy. Okay. Here, yeah, maximum information gain and maximum gain ratio. Any questions? Constructing tree. Constructing tree, did anyone went through? Should we draw the tree or can we use this information?
I think in exam they might not ask full tree because it's a very computational. Maybe the main node, the root node selection itself is a good amount of computation.
The first level alone, like let's say.
First level alone, yeah, outlook is the root node it came, right?
Right, okay. So here entropy of S again, and then the outlooks and outlook. Sunny, the same entropy.
Someone can correct. I mean, gain ratio, we until and unless it's mentioned in the question, we no need to calculate, right? Or any ID columns are given. My understanding is gain ratio is helpful for ID sort of columns are given. ID or date.
I'm not sure. Okay.
For them, the information gain is also, and it will split the tree into all leaf nodes only. Every row will become a leaf node kind of. For student ID, someone can correct. That's my understanding.
We are saying normally it's fine if we find the information gain alone. So here.
Yeah, we can take decisions with that itself because most of the attributes we can come up with the information gain, but there are certain attributes like in the column there will be a serial number or ID, right? So ID is always, I mean,
unique.
It's unique and it won't have any impact on the output variable. But if you calculate information gain for that, we will get maximum gain. And if you take that and split, construct the decision tree, it will make all the things into leaf nodes. So that's where this gain ratio is helpful. It will regularize or penalize that sort of attributes.
Meaning like we can have gain ratio for continuous variable. For categorical, we can not just continuous.
No, not continuous variables. For continuous variables, there is other thing actually. It's a split, like kind of income column, right? We need to split that, like greater than 25K. But what I'm talking is, suppose there is a student ID. If you have a student data and you have a student ID, ID will be just 1, 2, 3, 4, 5, 6, 7, right? And and if you consider that column, reprocessing is not remove that column, and if you are still that attribute is still there, and if you use that attribute in the decision tree calculation, and if you find the information gain either using entropy or Gini, it comes as one only. It will come as one. It will be having maximum information, and that won't be useful for us to construct the decision tree. For those kind of either we need to do pre-processing to exclude that, or we need to apply gain ratio.
Got it. Yeah. Thank you.
But only my question was like in the exam how it comes, and that's only whether they mention explicitly gain ratio for general scenarios also, and that part I'm not clear.
Yeah, at least in this question, they've asked the information gain, not the gain ratio.
To construct the
Here it
tree,
is.
they will. Sorry, to construct the tree, they will ask explicitly in the question, right? Otherwise, we need not to do that.
They will mention to what extent we need to calculate. Either they call. Can we go to that example question?
Yeah.
They asked the A2 attribute to they asked.
Yeah.
Yeah, but here it is only information gain, yeah, not the tree.
Tree, yeah.
Yeah, tree, I think they'll mention. I know which attribute will be used to determine the branches, right?
And
Like
that they
what is
asked
the
only
root
for
node?
A2 attribute, right? It's not for all attributes. In the question, if you see, they asked for only A2 attribute. A1 is not asked.
Yeah, yeah,
I
but
think that
another variation he's asking, what, in case if we want to construct a tree, what will be the question? As you mentioned, find the root node of the tree, right?
Right.
So the question will be like, what is the root node? Um, so here I think Outlook is the one which is having a maximum gain at the first entropy or information gain calculation. So where is it? Here this is where it starts. So Outlook will be the first node, right? And then they will split the table based on Outlook. Even I'm not sure, I don't recall drawing the tree for it. So it will branch out as sunny.
Right. How many categorical things are there for, right? Those many splits will happen. In that, we found already overcast is there are overcast, I think there are 3, 4 will be there. 3, I think, overcast. You go little up. Oh yeah, sunny is one thing.
In that specifically, they're taking Outlook sunny,
That's
splitting
when
the
splitting, right? So after if after you choosing the root node of Outlook, and it will go to 2 to 3 sub branches based on how many categorical values are there for Outlook. Here in this case of for Outlook, if you go to the main table, you can see how many. See here
right,
in
it is 3. Yeah, sunny, overcast, rainy. 3.
yeah, that means from the root node there will be 3. Uh, it should goes to 3 child nodes, and we need to
Okay.
compute for given Outlook and sunny. What would be the next node? Is it temperature or humidity or windy? Again, we need to compute information gain for all those 3. Now considering Outlook sunny is the
Okay. So here E of S will be Outlook of sunny.
yes.
Okay, the entropy of S is specifically for Outlook of sunny.
Yeah.
Okay.
And then again, we will compute for temperature, humidity. Yeah, that's right. Full construction, full decision tree will be a very, I don't think it's one, it may take more than 1 hour.
A lengthy one.
Oh my God, yeah. So okay. So here, just for understanding, here they've ended splitting the table based on humidity, right? So this will branch out of Outlook equal to sunny.
Yes, yes. Whatever is the previous, correct. That's correct.
Okay.
In the PPTs, if you go to the class, right, any example you will see in our PPT.
Decision tree.
Decision tree might be last seventh, I think, seventh or eighth. It will go like that. Yeah, this one. Yeah. In this case, overcast is a what we call this pure node. It's a leaf node. It will
All
be
of them will have yes, sir. Like that.
yeah, yes, it's a pure node. So we can directly this will become leaf
No
node.
more split. Okay.
No more split.
Because it's a complete 4 and a 0. So it ends there itself.
Yes.
Yeah. All the examples are corresponding to plate n is equal to yes.
For overcast, yeah.
Then yeah, humidity high normal. Okay, and here also it after finding for normal, it is yes and no. Okay. If the features are continuous, internal nodes can test the value of feature against the threshold. Okay. Any questions? I think yeah, we are done going through all of the programs.
Um, how to solve a maximum likelihood estimator means those problems to find theta and all. So do we have any means automation to calculate that as well? Yeah, this first one itself. Yeah.
Yeah, even I was looking, but yeah,
I don't
it's
think
not
any
there.
is there yesterday. We need to.
All right. Anything else from anyone? Did want to present? Yeah, I can. Oh my God, Sumil Koshla is in this meeting. He is. And thanks, Sumil, if you're listening.
Yeah, actually, because of him, I have hopes now for this subject. Otherwise, I had lose.
We all owe you big time, not for just this sem, but for the first sem
Yeah.
too.
Yeah, true.
Thanks a
We
lot.
have
Right.
Sumil in the call, is it?
Yeah.
Sumil is there, but I guess I don't. I think he's not listening. Maybe.
Sleeping.
Yeah.
Hello, Manoj, we can
Yeah.
hear.
Yeah.
Hello.
Yeah, hi Praveen. Yeah,
Okay, sorry,
we are.
nobody's talking. I thought.
I think, yeah, I think, thank you so much for everyone and the contributors for this code and explanation by, yeah, Revathy, Shankar, Satish,
I
and
think we should continue this one on
Manoj, Manoj for contributing this. Yeah.
not just for exam, we should continue for general understanding.